This is the Year 8 Numeracy Procedural test from 2013. Question 1. Something add 5.4 equals 10. So what I would do here is I would add on to the 5.4 until I reach 10. So what would I add on to 5.4 to take me up to 6? Well, that would be 0.6. So there's the first part of my answer. Now, what do I add on to 6 in order to get up to 10? Well, it is 4. So I get an answer of 4.6. Now, the second one is very similar. What I would do is add on to the 678 until I get up to 1,000. So what would I add on to 78 in order to get up to 80? Well, that would be 2. So I'm at 680 now. So what would I add on to 680 to get up to 700? Well, that would be 20. So altogether, I've added on 22. And finally, what would I add on to 700 to get up to 1,000? It would be 300, giving me my final answer of 322. Question 2. Estimate the total cost of these items. Now, what I would do here is I would round these to the nearest pound. So, for the camera, that would be £70. For the CD, it would be £16. For the mobile phone, it would be £48, and for the saucepan, £5. So I would add those up, and that would give me my estimate. Now for the units column, that comes to 19, so carry 1, and for the tens column, that comes to 13, giving me £139. Question 3. Work out 3/10 of £70. Now, working out a fraction of amount is a two-step thing. First of all, what we would have to do is divide our 70 by the denominator of the fraction, which would give us 1/10 being 7. And the final step would be we would multiply our answer by the top of the numerator of the fraction, and that would give us 21. So the answer is 21. Question 4. 7 multiplied by 0.9. Now, in order to do this, I would ignore the decimal point to start off with and do 7 times 9, which is 63. But I can't really ignore the decimal point, and what I notice is in the question we have a 1 decimal place number, so our answer also has to have 1 decimal place. So the decimal point would move in 1 place from the start of the number, and the answer would be 6.3. Now, the second question, 4.8 divided by 6, it's very, very similar. What is 48 divided by 6? Well, that is 8. But our original number has 1 decimal place, so our answer must have the same, so we move the decimal point in 1 place from the start, which gives us 0.8. Question 5. The bill for 5 people at a restaurant is £73.55. They want to divide it equally. How much does each person pay? Well, the word is in the question. This is a divide. So what I would do is a traditional bus stop division. So, what we must do is ask ourselves how many 5s go into 7. The answer is 1 5 because 1 5 is 5, remainder 2. How many 5s are in 23? Well, 4 5s make 20, and the remainder is 3. How many 5s go into 35? 7 5s make 35. And finally, how many 5s are in the last 5? It's 1. So each friend would pay £14.71. Question 6. This is a conversion graph changing between degrees C and degrees F. So, our first question is, what is 10 degrees C in degrees F? Well, first of all, we have to find where 10 degrees C is on our graph. And 10 degrees C would be here. So we would draw a line up to the graph, and then we would draw a line across and read off. And obviously, I can't draw very accurately on my iPad, so you would need to use a ruler here. So the answer for this question would have been, it's 50 degrees F. Now the second part is, what is 48 degrees F in degrees C? Well, the degrees F axis is the vertical axis. And if you take a little look at the bottom part of the axis, when you're checking out the scale, you will see that there are 5 little squares between 0 and 10. That means that every little square is worth 2 to get from 0 to 10 in 5 little steps. So 48 would actually be 4 little squares above 40, which would be around about here. So we would go across to our graph and we would read, whoa, gosh, it's very difficult to draw this. We would read down, so it would be 9 degrees C. But obviously you would need to do this with a ruler. Now the final question is quite interesting, just at the bottom of my screen here. It says, estimate 21 degrees C in degrees F. Now, what you might notice is there isn't a 21 degrees C on the degrees C axis. So what would happen normally is we would have to extend this axis. So it's going up in twos, so 16, 18, we're talking 20 would be around about here, and 21 would be roughly where the middle part of the page is, where the grey faint line is. So if you could imagine the original line extending to here. Now it says, what would this be in degrees F? Well, I think if we sort of take a little look across, I think we're talking in a region of about 70 to 75 degrees. So I would opt for something in that region. Question 7, 2 to the power of 5. Now a lot of people make this mistake of going, oh, it's just 2 times 5, which is 10. But that's not actually true. What it means is it means 2 times itself 5 times in a row. So 2 times 2 times 2 times 2 times 2. Well, 2 times 2 is 4, times the next 2 is 8, times the fourth 2 is 16, times the final 2 is 32. Question 8. Work out 151 times 27. Well, there are so many different ways to do long multiplication, I have to pick one. So I'm going to do a two-way table where I partition the numbers into hundreds, tens and units and then multiply it out. So I will demonstrate this by drawing out the grid. So the key thing to remember with this grid is that when you are multiplying, there are often lots of zeros, so you must add the correct number of zeros. So if I start with the top left square, I've got to multiply 100 by 20. Well, mentally, really all I do is 1 times 2, which is 2. But then I add the 3 zeros that I've seen in the numbers. The next one, top middle, it's going to be 50 times 20. So I would do 5 times 2, which is 10, and then I've got a 0 in the 20 and a 0 in the 50, so I must add both those zeros. And the final one, top right, is 1 times 20, which is just 20, so that's a nice easy one. Okay, bottom left, 7 times 100 is 700. Bottom middle, 7 times 50 is really 7 times 5. But then you add the 0 because it's worth 50. And finally, 1 times 7 is 7. Now, what helps next is if you add up each of those columns with 3 numbers. So my top column would have been 3020, and my bottom would have been 1057. And if I add those together, it gives me the grand total, which would be 770 and a 4, so 4077. Question 9. Work out the volume of this cuboid. So volume of a cuboid is worked out by using length times width times height. So what we've got here is we've got 10 times 3 times 4. Well, 10 times 3 is 30, and 30 times 4, you do 3 4s, which is 12. Because it's 30 times 4, it's got to have a 0, 120. Question 10. If 20 pence cost £3.60, how much do 4 pence cost? Well, there are a number of ways to do this. You could try and work out the cost of 1. But what I'm going to do in this question is I'm going to work out the cost of 2 pence to start with, because it's very easy to turn the original 20 into 2. And what I do there is I divide both numbers in the original statement by 10. So its 2 pence are going to become 36p, because when I divide the decimal above, the digits all move over one place, so that's 36p. Now, if I know 2 pence cost 36p, I know that 4 pence will be twice that amount, so it's going to be 72 pence. 0.72 pounds. Question 11. In order to solve this question, we have to use the word bid mass. Now bid mass helps us remember the order of operations, and we have to do our calculation with this word in mind. B stands for brackets, I stands for indices, and the last four stand for the four mathematical operations: division, multiplication, addition, and subtraction. So in our first question, let's take a little look at this. Well, what we've got here is we've got a multiplication and an addition, and multiplication is higher up in the order of priority than addition, so we would do the multiplication first. So this would become 7 add 12, and then when we add those two together we get a grand total of 19. Now the second question, we have a subtraction and addition, but we also have a bracket, which is actually the top of the word bid mass. So we would need to work out the contents of the bracket first. So inside the bracket we have a 9 and 8, which is a 17. Now the next thing we've got to do is take these numbers away, but 15 minus 17 is going to give us minus 2, because we're taking away a number that is 2 bigger than the number we're starting with. Question 12. If 8.5p is the cost of 100 grams of carrots, what is the cost of 2 kilograms of carrots? Well, what I would do here is I would scale up this particular amount. So we've got 100 grams of carrots, sorry. So it would be quite nice and straightforward to turn this into 1,000 grams. Now what we would do here to do this is we would simply multiply by 10. But whatever we do to one number, or in this particular ratio we do to the other. So multiplying 8.5 by 10 would turn it into 85p instead of the original 8.5p. Well, as it happens, 1,000 grams is 1 kilogram. So if we want 2 kilograms, we would simply double this to give us our 2 kilograms or 2,000 grams. So again, whatever we do to one side, we do to the other side of the problem. And doubling 85p would give us 170p. Or, as the question's got a pound sign in the answer space, we would have to put £1.70. Question 13. 50.2 minus 3.09. Now, I was thinking about putting this in columns in order to subtract this, but it could also be done very quickly mentally. If we were to make these decimals both have 2 decimal places, then what we have is the first number 50.20 and the second number 3.09. Now if we work separately with the whole number part to the decimal part, you could actually do 20 hundredths, take away 9 hundredths, which is going to give us 11 hundredths. And if we work with the whole number part, 50 minus 3 is 47. So it was actually very nice to do mentally. But you could obviously do it in columns as well. Question 14. This is a scatter graph about members of a running club, and it shows us on the horizontal axis how many miles per week they do in training, and on the vertical axis their marathon time in hours. So what are the questions? Well, underneath the graph it says another runner in the club ran 80 miles per week in training. Use the graph to estimate the marathon runner's time. Well, if you notice above the 80 hours a week, there is a great big gap here. So we have got to try and put our person where the rest of the crosses are sort of heading. Now, what I would do here is I would look at this graph and try and imagine it as a channel or a road. And question 14. Now, what we've got here is a scatter graph about members of a running club. And what we have here is on the horizontal axis, we have miles per week they do in training, and on the vertical axis is their marathon running time in hours. So, the first question says, another runner in the club ran 80 miles per week in training. Use the graph to estimate the marathon runner's time. So what I would do here is I would always say to you, try and look for the trend in the crosses. Is there a pattern? And what we can see is these crosses are generally slope going in a downward direction as the graph moves from left to right. Now I would always try and put a little channel amongst these. So I tend to put them, it's almost like the curb on a road. So all the crosses lie within the road. Now what you can see there is that we are now able to place the cross for this marathon runner. If they're doing 80, as long as we plot the cross for that marathon runner somewhere within this channel, then we would have a correct answer. So the marathon runner could actually go anywhere within this cross. So I would probably go for my first option. So I rub out my second cross. So that's where I would have gone for as my marathon runner's time. So that would have been, if I read across, it's going to be roughly there, which would be 3 hours 10 minutes. Now the second question is, what type of correlation does this scattered graph show? And when the crosses go downhill from right to left, then from left to right, sorry, I should say, this is called a negative correlation. Question 15. Work out 1/6 add 3/4. Now, we cannot add or subtract fractions that have a different denominator. So in order to make this problem possible, we have to turn the fractions into two fractions that have the same denominator. One very quick and easy way is to multiply both fractions by the denominator from the other fraction. That means I'm going to multiply the first fraction by 4 and the second fraction by 6. So if I multiply both parts of the first fraction by 4, 4 times 1 on top would be 4, and on the bottom 4 times 6, 24. The second fraction, if I multiply both parts by 6, on top 6 times 3 is 18, and on the bottom 6 times 4 is 24. And then if I add the fraction up, remember, don't add the bottom numbers, the answer would be 22 divided by 24, 22 24ths. Now this can be cancelled down even though the question doesn't ask for it, and if you half both top and bottom, you would get 11 12ths as your final answer. Question 16. This pair of boots in the picture were originally £45. The price is going to be reduced by 40% in the sale. So what is the sale price of the boots? Well, the easiest percentage to work out to start off a problem like this is to work out the 10% value of the boots. Now to do this, you would divide the price of the boots by 10. So that would give us £4.50 as the 10% value of the boots. Now 40%, however, is obviously a bit bigger than 10%. It is in fact 4 times bigger. So what we would have to do is we would have to multiply our £4.50 by 4, which actually gives us, it's very easy to do. A quick method of multiplying by 4 is to double and double again. So if we double £4.50, that's £9, and we double it again, it is £18. Now, the actual question is, what is the sale price of the boots? So what we now have to do is we have to take the original price and take off the discount. So I'll do this very similar to the subtraction I may have done earlier, which is where I'll add on to the 18 until I get to 45. So 18 add 2 is 20. I'll just jot these down. Then 20 add what gives me 40? Well, it's 20 add 20. And then to get from 40 to 45, I add on 5. So I have added on a grand total of 27. So the sale price is £27. Question 17. I need to turn 2.5 kilometers into centimeters. Well, probably the first thing is 2.5 kilometers could be written in decimal form, which is 2.5 kilometers. Now, to go from kilometers to meters first, you would times by 1,000. So 2 kilometers is actually going to be 2,500 meters. Now, to go from meters to centimeters, you would times by another 100. So that would be a case of making it another 2 zeros on the end, giving us 250,000 centimeters. Question 18. Joe and Gwen share £840 in the ratio 3 to 4. How much do they each get? Well, the first step in a ratio division in a ratio question is to add up the numbers from the ratio, which give us the fact that there are 7 parts to this ratio. Next, we would divide the money between those 7 parts. Now, how many 7s are in 84? Is 12, and we add the 0, so that means each part is worth £120. Now, what that means is Joe, he's going to get 3 parts, because his name was mentioned first, and 3 is the first number in the ratio. So I do 3 times 120, and that means that Joe is going to get 360, and Gwen, who was mentioned second in the sentence, and her number is 4 in the ratio, she's going to get 4 shares, which is 4 times 120, which would be 480. Now, it's always a good idea to check these by adding both numbers up, and they should make the 840. These do, so we've done this right. Question 19. Round 475,604 to 2 significant figures. Now, 2 significant figures mean we have to draw a cut-off point after the first 2 digits in this number. So, the first 2 digits are either going to stay as 47, or they may go up and become 48. Now, to decide whether this happens or not, I need to look at the next digit, which is the 5. Now, we know the rules for rounding are, if a digit is 5 or more, we round up. So I am going to round the first 2 digits up, and they're going to become 48. Now, what we must then do is replace each of the other digits with a 0. And we will have as our answer 480,000.